Hi everyone, this will be your video that corresponds with your geometric sequences packet or your geometric sequences online assignment. So you can have that assignment open, you're going to be typing in and filling in the blanks with me. So here we go. On the first page, we're just going to kind of talk about what is a geometric sequence and what is the common ratio. And that's really what makes this sequence geometric when it has a common ratio. So let's get into it. So the first thing we can talk about is what is a geometric sequence. So it's going to be a ratio. So it's a sequence when the ratio between consecutive terms is a constant. Okay, so what that means is basically each term in consecutive order, basically meaning the fifth term and the sixth term, they're consecutive. The ratio between those terms will be a constant, and no matter what terms you're looking at, it'll be the same ratio. Now what we call that is our common ratio. So this is something important. This is something that we're going to be finding for all of our problems here. So this is our common ratio. And when we're finding that, we're essentially taking any term and dividing it by its previous term. So we can fill in here for this a sub n. This is just going to mean any term. Now, to be specific, we just have to say after the first. We can't do this without the first term. Okay, so any term after the first, a sub n minus 1 just means the previous term, just like last week. So what we're doing here is we're going to be taking any term, we're going to divide it by its previous term, and that's going to help us find the common ratio. So let's zoom in. We're going to zoom in on this example here. It's a little tiny, so we'll make it nice and big. So it's asking us to find the common ratio of this sequence. So you could take any term. So for instance, I can take this negative 54 if I want to start here. And I'm going to divide it by 18. So if I do negative 54 divided by 18, I'm going to get a negative 3. Now maybe if I started at 18 and I divided that by negative 6, you're going to see that I also get negative 3. And if I were to try one more time, if I do negative 6 divided by 2, that also gives me negative 3. Okay, so one little note I want to add on here. Okay, so since all common ratios are equal, this verified, we are working with a geometric sequence. Okay, so our common ratio, it was exactly the same no matter what pairings I looked at. It was always going to be negative 3. So we're able to say R equals negative 3. One of the reasons that we need to find R is to be able to use it to write a rule. So again, we need to remember what we were talking about last week. And I'm just going to do a little side notes over here. So you're just going to not see the page for a second. And here's a little note for us. So we do need to remember the difference between recursive and explicit. So for instance, this first example that we're going to be working with, it's going to be teaching us how to write a recursive rule. So what that means is that a recursive rule is going to rely on previous terms. And an explicit rule, you can find any value, you can find any term without any of the previous terms. So you can find any term without needing a previous term. So we need to make sure that we truly understand the difference here, because when we're writing these rules, which we can consider like an equation, we need to make sure that we're using the appropriate method. Do I need a previous term for this, or can I write one without it? So let's go back to our worksheet here. So when we're looking at our next area that we can fill in, it's telling us how to write a recursive rule for a geometric sequence. So what we have to remember is that, and it's already typed in here for us, is that when you write a rule for a recursive sequence, arithmetic or geometric, you need to have your initial value. So you need to have your a sub 1. So for us, our rule for this, we're going to have a sub n equals, and it's going to be r times a sub n minus 1. So we have our common ratio times our previous term. Okay, so when we're writing this out, and I'm just going to write down here so we can scroll down here, this is how we find our rule. And we also need to say when a sub 1 equals something, okay? And we're going to fill in like the blank here. We need to have both pieces here. So that's everything we'll need for our answer. So let's work on this problem. So there's two things that we need to find. We need to find a sub 1, and we also need to find r. So a sub 1 is generally going to be your easiest thing to find. It's just your first term. You look at your list of numbers, find your first term. Ours is 2. Now let's try to find our r. So we talked about this at the top of the page. R, you can find that by taking any term and dividing it by the previous term. So for instance, if I take negative 128 and I divide it by 32, I can use a calculator, and I'm going to find that this is going to give me negative 4. And no matter what pair you chose, if you chose 32 and negative 8, you'll also get negative 4. So that's our common ratio. So to write our rule here, we're going to have a sub n equals. Now we figured out that our r was negative 4. We're going to leave a sub n minus 1 because that just means we're going to take a previous term times negative 4. But we do need to fill out when a sub 1 equals, and we figured out our a sub 1 was 2. So you always need to have that initial value or your very first value listed. We can figure out the rest of these values here. So for instance, this is when n equals 1, 2, 3, 4, 5, 6, and 7. So if I were trying to find a sub 5, I would do negative 4 times a sub 5 minus 1, which is negative 4 times a sub 4, which is the previous term. So it's going to be negative 4 times negative 128. And we'll be able to fill in that this is going to be 512. Okay, so you could find that for your 6th and 7th term, but just to save a little bit of time, we're going to have negative 2048 and then 8,192. So 8,192. Okay, so here we are on the next page. We finished our recursive rule. Now we're going to work on writing an explicit rule. So let's zoom in on this top empty space for us to fill in some notes here. And we can fill in our rules. So we're going to write this out, and it's going to be a sub n equals a sub 1 times r to the n minus 1. Okay, so again, this a sub 1 will always mean that this is your first term. And your r to the n minus 1, this n still stands for that term number that we're looking for. This is exactly the same as last week. It'll be the same as next week. So always remember, a sub 1 is your first term, and n is the term number we're looking for. So there is a small typo in here. You can cross this out, and you'll write explicit. Okay, that was a typo. It should say find the explicit rule. So there's two things we need to find. We need to know our a sub 1, and we need to know our r. So again, a sub 1 is pretty easy. It's always your first term, so we have a 3. And our r can be found by finding our common ratio. And remember, that's just any term divided by the previous. So if I take negative 24 and divide it by 12, I get negative 2. And I could do that with any of my terms here. If I take 12 and divide it by negative 6, I also get negative 2. So we're going to have a sub n equals, this is just my formula down here, a sub 1 times r to the n minus 1. So we're going to plug in what we have. So a sub n equals, we're going to have our a sub 1, which is our first term, is 3 times our r is negative 2. Now notice that this is negative, so make sure you use parentheses. If not, it looks like you're writing 3 minus 2. So we have negative 2 to the n minus 1. So this is our rule here. Okay, so that's our rule. And then now with this, we can find any term we want. So they're asking us for the 11th term. And what's great is we don't need to find the 5th, 6th, 7th. We don't need to find every single term to get to the 11th. We can just plug in 11. So you can see how I replaced it in my a sub n. Now I have a sub 11, meaning it's my 11th term. I'm going to have negative 2. Now my power is going to be to the 11 minus 1. So it's going to be 3 times negative 2 to the 10. Okay, major note here is to make sure that you're using your order of operations. Okay, so when we do, you really have 3 times, and negative 2 to the 10, I'm going to plug that into a calculator, and I have negative 1,024. Then we can multiply the 3. So make sure you are finding your order of operations and you're not doing that multiplication first. So you're going to take that negative 1,024 times 3, and you get 3,072. And there we go. We found our 11th term, so we can call it our a sub 11, and it's that value. All right, last thing to talk about with these, geometric sequences is how to graph them, okay? So we can graph them. You're going to notice that this table looks like a good old-fashioned input-output table, and when we graph them, they're not going to create a line, so that's what we need to be careful with. So looking at our blank up here for our vocab word here, we have the graph of any geometric sequence will consist of discrete points, which just means a lot of points, that lie on an exponential curve. Okay, so it's letting you know it's not going to be a parabola, it's not going to look like a cubic function, it's not going to be a line, but it will look like an exponential curve. So for instance, just to give you an idea of what the shape of an exponential curve looks like, if we have this one, we might have one that's kind of curving upwards like that. And then our other option would be as if it were decaying or going downwards, and it would kind of look like this. All right, so remember, it's going to be a curve, it's not going to be a line. You can just connect the dots and make it a nice and smooth curve. So looking at our table here, we can fill it in. We'll find our a sub n's, and then that'll give us a point. So what you can remember is that our points are going to look like n, comma, a sub n, which is really similar to x, y. So filling in what we have, we're going to have a sub 1 equals 2 to the 1 minus 1. So it's 2 to the 0. And another important note is that anything to the 0 power is 1. So maybe write that out. So anything to 0 power is 1, okay? Super important to remember that. Let's move on. So we're going to have a sub 2 equals 2 to the 2 minus 1, which is 2 to the first, which is 2. A sub 3 is 2 to the 3 minus 1, which is 2 to the second, which is 4. A sub 4 is 2 to the 4 minus 1, which is 2 cubed, which gives us 8. And a sub 5 is 2 to the 5 minus 1, which is 2 to the 4th, which is 16. So clearly I went pretty quick on that just because you're watching a video, but when you're working on this, just use a calculator. Take your time, make sure you're doing your orders of operations, and you just find your input, plug it in, and you get your output. Once you have this, you can see what points you would have, and you can even create another column on your table here. And this is a really great habit to get into so that you're not making mistakes, and the points are going to be n, comma, a sub n, kind of like x, comma, y. So we could just get that together so that when we're working quickly or we're working on our graph, we don't have to look at too much. So we have our points 1, 1, 2, 2, 3, 4, 4, 8, and then 5, 16. So those are our points that we're graphing. So notice on this graph that we're going up by 2's. Each block represents 2, so we're only going to go up halfway for 1, 1. We have 2, 2, 3, 4, 4, 8. Now we do technically have 5, 16, but that's not going to fit on our graph, and that's okay. We're just going to connect this with a curve. A little more. Nothing too crazy. Put an arrow on the end. And this problem's complete.